Welcome to Day 11 of Math 111. We are going to be talking about addition and subtraction today. There are two models for addition. These are the set model and the measurement model, sometimes referred to as the number line model. Before we get into the models, we're going to talk about the terminology. With addition, the two numbers that are added are referred to as add-ins. And the result of the addition is the sum. So we add a pair of add-ins and get a sum. The first addition model that we're going to talk about is the set model. The name of this model comes from the fact that we are typically adding sets. Here's an example. Two families are planning a cookout. The Smith family has 4 members and the Jones family has 5 members. How many people will be at the cookout? You can see that you are adding the quantities of members in each family to get the result. So this addition problem would be 4 plus 5 equals 9, where 4 and 5 are the add-ins and 9 is the sum. Here's another example of the set model. Maria has 5 pencils in her backpack, and Tanya has 8 pencils in her bag. How many pencils do they have all together? This is again the set model because we are combining the two sets of pencils. Sometimes we can use a Venn diagram to help with the addition. We've talked about a Venn diagram in a previous lesson, so this is good review for us. Let's look at this example. In a survey, 20 students indicated that they like chocolate chip cookies. 25 students indicated that they like brownies. If 15 students like both chocolate chip cookies and brownies, how many students were surveyed? So the intersection of the sets is 15 students. There are 15 who like both chocolate chip cookies and brownies. We subtract to get the other numbers. So there are 5 students who like chocolate chip cookies and not brownies, and there are 10 students who like brownies and not chocolate chip cookies. So we add the quantities from each of the 3 regions of the Venn diagram, 5 plus 15 plus 10, and we see that we have a sum of 30. Let's move to the measurement model. Sometimes this is referred to as the number line model, and we will see that in diagramming these, we will use a number line. Here's an example. Andre likes to stay fit, so he runs a lot. Yesterday, Andre ran 2 miles before he went to work, and he ran 3 miles after he got off work. How many miles did Andre run yesterday? So to model this, we will begin with a number line, and we will draw arrows to show the add-ins. Since Andre ran 2 miles before work, we start at 0 and hop 2 units. And notice the arrow begins at 0 and the arrowhead is at 2. After work, he ran 3 miles, so we draw another arrow that begins where the first one stopped. And we hop 3 units, and the arrowhead now ends at 5. So we see the add-ins 2 and 3, and the sum is where the second arrowhead stopped. The sum is 5. Here's another example of the measurement model. It is 5 blocks from Gwen's house to Rochelle's house. It is 3 blocks from Rochelle's house to the middle school. If Gwen walks from her house to Rochelle's house, and then from Rochelle's house to school. How far has Gwen walked? Again, we start with a number line, and we represent the 5 blocks that Gwen walked to Rochelle's house with an arrow starting at 0. We hop 5 units. The first arrow stops at 5. And the second add-in is 3. This is the distance from Rochelle's house to the school. We start at 5, where the first arrow ended, hop 3 units, and the arrowhead of the second arrow is at 8. So the add-ins are 5 and 3, and the sum is 8. We have 4 properties of addition that we want to go through right now. The first one is closure property, and the commutative property, the associative property, and the additive identity property of 0. Let's define each one of these. The closure property means that when we add 2 whole numbers, then the sum is also a whole number. So the result is in the same set where we got the 2 add-ins. The commutative property means that the add-ins can be swapped, and the sum will be the same. So A plus B is the same as B plus A. The associative property has to do with how we group the add-ins. This property says that addition can be performed in any order and the sum will remain the same. On the left side, we can see that we're adding B plus C first, and that is added to A. On the right side, we see that we're adding A and B first, and then adding C. The last property is the additive identity property of 0. When 0 is an add-in, the sum is equal to the other add-in. So A plus 0 is equal to 0 plus A, which is equal to A. We want to move to subtraction now. There are 5 models for subtraction. Take these one at a time. Before we move to the takeaway model, let's look at the terminology that we'll be using. The minuend is the first number in the subtraction. The subtrahend is the one that is subtracted from the minuend, and the result is the difference. So minuend minus subtrahend is equal to difference. And now for the takeaway model. Here's an example. Marcia has $8. She gave $3 to her best friend. How many dollars does she have left? You can see the idea of taking away or giving away some quantity there. What is the minuend? What is the subtrahend in this problem? Finally, what is the difference? The minuend is 8. The subtrahend is 3, and the difference is 5. Did you get them right? I hope so. Sometimes it's necessary to model with manipulatives. And the takeaway model is literally done by taking away. So you build the minuend. So in this case, Marcia has $8. We'll put out 8 square tiles. The subtrahend is 3. We literally take them away. And the difference is what is left. To draw this on paper, you would again build the minuend. Here we have representation of the 8 tiles. We will circle the ones that we're going to take away and draw an arrow off the page. And you can see this diagram on the right side. This next model is the missing addend model. Here's an example. Tickets for the upcoming concert are $10 each. Joni has $7. How many more dollars does Joni need in order to purchase a ticket to the concert? In order to model this with manipulatives, you would begin with 7 counters. This is how much money Joni actually has. The question is, how many more dollars does Joni need? You add enough counters in order to bring the total to 10. The answer is the number of counters that had to be added. Again, this is the missing addend model. To draw this on paper, begin with the amount of money that Joni has, which is $7. Determine how many dollars are needed to reach the desired sum. Draw a circle around those that are added and draw an arrow to the first pile. The diagram is drawn here. This is the comparison model. Darren has 8 baseball cards. Derek has 5 baseball cards. How many more cards does Darren have than Derek? Notice that you are comparing quantities that each boy has. To model this with manipulatives, you would lay out the number of items that each student has. So Darren has 8 baseball cards, and I have represented it here with 8 yellow color tiles. Derek has 5 baseball cards. I have represented those with 5 red tiles. You pair up the elements from each set, as I've done here. The result is the number of counters that are left over. To draw the model on paper, you would do something very similar. You would draw figures for each boy. Since Darren has 8 baseball cards, we draw 8 shapes for Darren. I've used triangles here. Derek has 5 baseball cards. I've used little rectangles for Derek's baseball cards. You'll actually pair them up with circles. The unpaired elements will be the solution to the problem, which is the difference. The measurement model is similar to what we saw with addition in that you begin with a number line. Here's an example. Marcella bought a roll of ribbon from Hobby Lobby that was 5 yards long. She used 3 yards of ribbon on a project at home. How much ribbon did Marcella have left? We first draw the minuend, which is 5 yards. Starting at 0, hopping 5 units, the arrowhead ends at 5. She used 3 yards of ribbon. So we draw this arrow backwards, starting at 5 and hop 3 units to the left. Notice that the arrowheads are together. The difference is the distance between the beginning of each arrow. So the distance between 0 and 2 is 2. This is the partitioning model. Mrs. Simpson bought a dozen plain and chocolate donuts. 4 of them are plain. How many donuts are chocolate? We have a note here. With partitioning, the items will fall into 2 or more distinct subsets. So there's no intersection, or the intersection is empty. To draw a model on paper, draw figures to represent the minuend and circle the known subset. The figures left over will represent the difference. You can see here that I've drawn a circle around the plain donuts. So that means the ones left over are the chocolate donuts. We're going to go through some examples, and I'd like you to determine which model is represented here. Mary has 5 reeds. Monica has 4 reeds. How many more reeds does Mary have than Monica? Think about which model this is. This is the comparison model. Did you get it right? Here's another problem. Lisa has 5 reeds. 2 of them have green thread on them. How many don't have green thread? Which model is this? This is the partitioning model. Another example. Linda has 5 reeds. She gave 2 broken reeds to me. How many reeds does Linda have now? Which model is it? Yes, it's the takeaway model. In this example, Lashandra's band director has asked her to have 5 working reeds at all times. Lashandra has 4 reeds that work. How many reeds does she need to buy? Okay, think about it. Which model is this? It is the missing add-in model. And one more example. Jackie drives 5 miles to my house for lessons. On the way home, she stopped for gas at a station 4 miles from my house. How much farther does she have to drive to get home? Did you get this one? This is the measurement model. Make sure that you understand the differences between each of the models for addition and subtraction. Good luck on your homework.